Okay, review today. We're going over page 78 in the textbook, questions 1 to 4, but we're not doing this one. All right, so for each experiment, state the possible outcomes. A spinner has equal sections labeled win, lose, and spin again. Okay, well, the outcomes are win, lose, spin again. That's it. A bag contains 6 marbles, red, black, and blue. Okay, so the outcomes are red, black, or blue. That's it, kind of simple. Tetrahedron has 4 faces labeled 1, 2, 2, and 3. So the outcomes are 1, 2, and 3. So there's only 3 outcomes. Okay, alrighty. So that one was hopefully very easy. Next, Dave tosses a coin 20 times. Heads is shown 12 times. How many times did tails show? Okay, well, we know that tails showed 8, right? Next, what fraction of tosses showed heads and then what showed tails? Okay, so this is the same thing as theoretical probability. So the theoretical probability of, oh no, wait, sorry, that's not. This is experimental probability because this is how many times it was actually the case. So since he flipped it 20 times, that's our denominator. And then our numerator is for the first one of heads, so 12. And then EP, you might see actually written like this, EPT, experimental probability of tails. So this would be EPH, like that. So experimental probability of tails was 8 over 20. Okay, are these results what you would expect? Explain, okay? No, they're not what we would expect, right? We would expect the theoretical probability. So we'd expect theoretical probability of heads to be 10 over 20, and then theoretical probability of tails to also be 10 over 20. So we would say what he got for tails was lower than what we would have expected, and then what he got for heads was higher than what we would have expected. Yeah, and then the explanation is being based upon our theoretical probability. Next, Dave tosses a coin 100 times. What would you expect the results to be? Okay, well, we would expect it to be like we would expect, I guess, the experimental probability of heads to be 50 over 100, and then same thing you would expect, or I guess this is, well, okay, I guess it's actually theoretical probability because this is what we would expect to have happen. And then the theoretical probability of tails, we would expect same thing to be 50 over 100. Explain, because there's equal chance of getting both. All right, next one. Avril spins the pointer on the spinner several times. Here are her results, okay? So let's just tally this up. She got, okay, so she got, let's see, what is that, 17, right? And then this one, she had only 7, okay? So how many times did she spin the pointer? So we know that she span it, what, 24 times. 24 times in total, because 17 plus 7 is 24. Okay, how do you know? We just added them together. Okay, next one is what fraction of spins were blue and what were orange? Okay, so now we have experimental probability of blue was 17 over 24. And experimental probability of orange was 7 over 24. Were her results what you would have expected? Okay, well, what we would have expected would have been the theoretical probability of blue. We would have expected to be 3 over 4. And then if we're finding that as an equivalent fraction, we would do our magic number as times by 6, right? So then we'd have 24, and then we'd have 18 over 6. So the answer is no. And then the same thing for this one, right? We would have expected, so it was experimental probability of blue, and with a theoretical probability of orange, we would have expected to be the same as 1 over 4. Magic number would be times by 6, right? So then it would be, we'd expect her to have 6 over 24. So the results were not what we would have expected, although they were very close. We would have expected the theoretical probability of orange to be 6, and then the theoretical probability of the blue to be 18. Okay, there you go. Next one, Nina and Algeria placed 35 red tiles and 15 yellow tiles into a bag. At random, they picked a tile from the bag, reported its color, and replaced it. Okay, they did this 100 times. All right. Oh, this is also important. We're not going to be in junior high. You guys will get to this, like what happens if they don't replace it. That means that like the number of possible outcomes always changes. But for ours, we know that the experimental probability is always going to be out of 100 because they always have 100 things. So for each color, okay, so they're asking us first of all, they're asking us the theoretical probability of red. So that is, let's see. Okay, so they have 50, right, in total, and then there were 35. Okay, so 35 out of 50. Okay, predict how many times Nina and Algeria should get the red tile out of 100. Okay, so then in theoretical probability of the red, if we had 100, we know we're just doing fractions, right? So multiply by 2, so it should be 70. Next, Nina and Algeria picked a red tile out of the bag 58 times. What is the experimental probability of them picking a red tile? So experimental probability of red was 58 over 100. Next, Nina says, I think we did something wrong. Do you agree? Why? Okay, well, you'd expect it to be 70, but she got 58. No, you didn't do anything wrong because that's just the chance, right? Like she could have gotten 72, she could have gotten something totally different. Yeah, she could have gotten 60. So it's just by chance? No, we don't think that you did anything wrong. That's just how probability and chance works. Okay.